Hello everyone, this is processing tutorial. In this video we're gonna talk about the concept of entropy. So in this video, I'm gonna cover the basic concept of entropy, which are these three bullet points. And for the part B, I'm gonna cover the cross entropy and Kell distance and mutual information. So in this video, we're gonna cover these three concepts. So let me first introduce the concept of entropy. The entropy is calculated by this formula here, which is summation of minus p multiplied by log px. So we can write this down with expectation, which is expectation with respect to p of log 1 over px. So this concept of entropy is often regarded as the degree of uncertainty. So why do we call this as the degree of uncertainty? Let me give you an example. Say we're having a basketball match tomorrow, and for the case A, the baseball game is a match between LA Lakers and versus the Jefferson High School basketball team. So what will be the outcome of this match? I guess LA Lakers gonna win this match. So I'll say the probability is 0.99. The probability of LA Lakers winning the game. And also there's a case B, and this time the basketball game is LA Lakers between Chicago Bulls. How about this time? So in this time, I roughly say the probability of LA Lakers winning the game is roughly the 0.5, because it's a toss-up between LA Lakers and Chicago Bulls. So how do you say the uncertainty of this match? Well, the uncertainty is obviously the case B has a bigger uncertainty compared to case A. But we need a mathematical expression to accurately describe this uncertainty. So for this situation, entropy comes in handy. So if we use this formula here, so we can easily calculate the probability, the entropy value of the probability P. So this graph here is entropy value HP in terms of the probability P. So as you can see, if P is small or if P is large, the uncertainty value is pretty small compared to the case of P equals to 0.5. If the probability is 0.5, which means the probability of winning the game is pretty much toss-up, the uncertainty is, in this case, the uncertainty is maximized. So we can see that if the probability value is equally divided and then entropy is maximized. So now I'm gonna move on to joint entropy. Joint entropy is pretty much the same, because instead of Px, we're using px comma y, which is joint distribution of pxy. So in this case, the entropy of hx comma y equals to nested summations with respect to x and y, and we write down this formula here, the same formula here. So in this case also we can express this entropy value with expectation, which is minus sign and minus sign multiplied by expectation with respect to px comma y of log px and y. So this is the definition of entropy to pair of random variables, in this case x and y. So finally, I'm going to mention conditional entropy. The definition of conditional entropy is a little bit different from the joint entropy, because in this case we're using a expectation with respect to px. So as you can see, we're taking we're using expectation with respect to px of the entropy of y given x. So since the entropy x can be calculated with this formula here, it is since px multiplied by py given x is equal to p x and y, you can write down the above formula into this form. So this boils down to minus sign times expectation with respect to px and y of log py given x. So be cautious, because these two have different forms. In this case we're using log, in this case we're using conditional entropy. So the conditional entropy can be calculate in this way. So remember, this form is not conditional entropy. So this form here is the final result. So you need to remember this. So this is pretty much all of today's lecture. So in part B, we're gonna talk about the cross entropy.